Okay, I think it's time to start. It's 4 o'clock or 1 minute past 4. So my name is Weihed, and I am Pro-Vice Chancellor of Luleå University of Technology and also chairman of the northern branch of Kungliga Ingenjörsvetenskapsakademin, the Royal Swedish Academy of Engineering Sciences. And today we will have a seminar on space and AI. And we are kindly hosted by the Swedish Institute of Space Physics. It's really nice that we could be here in Kiruna. A few words on the academy. It's the oldest engineering academy in the world. We turned 100 years 2-3 years ago, I think. Roughly 1,000 members in the academy, spanning all kind of engineering fields, quite a big number of international members as well. And I'm then representing the northern branch of that academy, which has its main localities in Stockholm, of course. We are based, as I said, in the north, and saying the north, I mean all the geographic area from Gävle in the south to up here in Kiruna. So we have more than half of Sweden as a geographical area to cover, which sometimes is a challenge, but it's so great to be up here in Kiruna. We have been here having seminars before, but I think it's now 4 or 5 years since we were here last time, so it's really due time to be back in Kiruna, and today discussing, of course, space and AI. So we have some interesting talks here today, and tomorrow we will have a field trip to S-Range. I'm also looking forward to that. And after the seminars today, we will go to the university part of this building and have some mingle after with some wine and refreshments and so forth. With that short introduction, I'm handing over to Torbjörn Minde, who will moderate today's seminar. And before you start, Torbjörn, I just have to mention that Torbjörn is a newly elected member of the Academy. That was decided the day before yesterday. So congratulations and welcome, Torbjörn.
Thank you. Yes, we will have a very interesting seminar today. The geopolitical situation, politics around the Arctic is increasing in tension. So when we discussed at IVA North, okay, what kind of seminars are we gonna organize for 2025? We said there is something in the intersection between space and AI would be very interesting because of this tension in the Arctic. Because with sensor data and the analysis of sensor data from space, it will be very important. And both of these two areas, they experience right now an exponential growth in interest and in business and so on. So the intersection should be really interesting. It should be an exponential as well, I guess. Have you audience, have you experienced an exponential function in your life before? I can just shortly demonstrate. Imagine you are in a water tank, like this big water tank. You're standing on a platform, and you fill water with an exponential function down there. And you look, and you look, and you look, and you're drowned. That's an exponential function. So you know it's happening. You either miss it or you're too early. You're too late or too early. It's very hard to hit that exponential function. Anyway, we're going to address this now with a couple of talks, short talks. We'll see if they can manage 100 slides in 10 minutes. We'll see. Anyway, after that, we're going to have a panel discussion. I have a couple of questions for my presenters and my panel. So we start this with Olle Norberg, the director of Swedish Institute of Space Physics. Welcome.
Thank you, Tor, and also welcome to everyone to Space Campus and the Swedish Institute of Space Physics. I'm going to start with my presentation. And space science and applications. At IRF, connected to the use of AI. That's the task I have in front of me here now. So just a few words about what is IRF, because we need to know what can IRF do before we can talk about AI and space. We've been around since the late 50s. We're under the Ministry of Education and Research right now. Roughly 50% of our income is from the government, and the rest is project money. And what really sets us apart from, let's say, university institution is that we have quite a few engineers and software developers, because we are doing our own instrumentation for space research. And the research we do, you can roughly divide it into these three categories. We are observing. We're doing instruments that can observe geophysical and atmospheric parameters for a long time. So we have roughly 50 different experiments running, mostly in the north of Sweden, but all the way down to Skåne, actually. We do research. The second bullet is doing research with those instruments, as well as IceCat and sounding rockets and balloons at S-range. And then we do solar system research, building our own experiments, flying them on spacecraft in the solar system. So when it comes to observatory measurements, which we've done for a long time, we have this kind of instrumentation going. You really need to measure long term. Do it since the 50s, and our ambition is to do it forever. The applications of this research, because it's mostly basic research, but nevertheless, the applications is that we can support society in understanding the effects of the solar wind on technical systems, on spacecraft in orbit, as well as on ground infrastructure, such as power lines. Power lines are susceptible to induced currents when we have solar storms. So our stakeholders is, for example, ESA, the Swedish Armed Forces, the Swedish Civil Continuous Agency, and, for example, Svenska Kraftnät, that wants to know when will we have some effects. And this is where AI comes in. Some of the machine learning tools that we're using right now is to trigger measurements, to go up in the highest modes of measurements when we see there are activities. So you see here in the bottom picture, different classes that we categorize all sky camera images in, and then we can trigger measurements. We are also going to use AI to interpret ionograms, the Abrahamsson data. We use physics-driven AI software. And we also, for a long time, actually, we've done products for the European Space Agency where we forecast solar wind effects. And this is the kind of data we do there. Magnetic disturbances, you maybe know about the KP index. We're forecasting that up to 4 hours ahead. The same with the ring current parameters and the aurora electrojet and the BDT. Those are the kinds of things that we use machine learning to forecast. Successfully, I would also say. This is, just by the way, we have an app which I hope you have downloaded and use it, because this triggers, based on the all-sky camera we have on the roof of this building, a push notice to users of this app. So do you know when to go outside and look at the aurora? One of the things that we do mostly at IRF is to study the solar wind effects on planets and moons, comets, asteroids, in terms of what does that particle environment and the electromagnetic fields that are connected to particles do with atmospheres and the surfaces of these kind of objects in the solar system. We're looking at the plasma interaction with these bodies. Currently, we have 15 instruments in operation on 13 spacecraft, as you see them listed here. You can also see that this is a long-term activity. Some of these have been up then for 22 years, for example, Mars Express. So it's not uncommon that these projects stretch over maybe 30, 40 years. That is something that is inherent in doing this kind of science. And of course, these spacecraft, they have no AI in them whatsoever. But in the future, I think we will do that. This is the project that we're working on right now. This week we have the Turkish Space Agency and their TÜBİTAK USAY, their space institute, here to interact with us when it comes to their next lunar mission, TLM-1, where we have instrument. And we also have instruments on a number of future, both Indian and ESA spacecraft, as you can see here. I have to mention again JUICE, because this is something we're very proud of. JUICE is a mission to Jupiter. It's a big ESA spacecraft, which was launched in April 23, and it will arrive in Jupiter in July 31. So it takes a while. It takes 8 years to get out there. And we'll study these interesting moons, Ganymede, Callisto, Europa, which have oceans under the crust, which is super interesting. What we're proud of is that we, as a fairly small institute in Sweden, are responsible for 2 out of the 10 experiments on board JUICE, the particle environment package and the radio and plasma wave instrument. Just a few pictures for you to see what it looks like when we build this kind of instrumentation. Lots of parts. We do everything in-house. We buy the electronic components, but everything is designed and built in-house. So this is what the complete package look like. And also where some of the sensors also then originate. Apart from particle experiments, which you see here up to the left, we are also doing, as I said, the electromagnetic fields and waves, the booms that need to be extended from the spacecraft to measure magnetic and electric fields. So, getting into the AI, this is the picture that I've looked at from OpenAI, and it talks about the 5 levels of artificial general intelligence. Because right now we're at the first level here, where you have ChatGPT and Gemini and the others, which are large language models. But general artificial intelligence, that's something else. And the thing is that it doesn't exist yet. But nevertheless, we can talk about what can it mean in the future. And it means rather amazing things if it happens. The 5th level here is something that I would think is almost a bit scary, because this is where humans are not really needed anymore. But if we can harness this technology, I think we can do some pretty amazing things. For example, we'll have colleagues in the 3rd level here, where they have agents. This is, let's say, a colleague which you can instruct to go and solve a task that would normally take a human maybe years to do. You send it out to do the work and come back with the result. That's the forecast. Well, let's see if it happens. But nevertheless, these are very exciting ideas, I would say. And how does that exactly translate into what we're doing? Well, I think all organizations, and now I want to talk about science organizations, I think that using AI can become extremely powerful tool for these kind of organizations. And vice versa. If you neglect to use these tools, I think you will fall behind. One of the things that I believe will be really a strength is to be able to do instrumentation yourself and own the data, because that is something that will set us apart from those that will just scour the internet of freely available data and try to do science on that, because they don't have the full knowledge about the data, or they don't own it, or have not the full access as you have when you actually have done the instrumentation yourself. Also, to combine experience, let's say experienced scientists that know the pitfalls of instrumentation, of what is doable, what will take longer time, with young people that know AI, I think that will become an extremely powerful combination. So what specifically can we use AI to do in space physics? Well, here's a list of what I think will happen when it comes to using AI on, for example, onboard to trigger event detection. This will happen both onboard as well as in the processing of data later on. But nevertheless, to be able to do this onboard will really help us to get much more data down to the Earth, in particular from missions where you go out much further out in the solar system and you have limited data transfer abilities. It will enable us to really look at large data sets from multiple spacecraft, multiple instruments, and to model this and to study the whole environment. Because right now, we as humans are limited in what we can sort of comprehend and process. And here we can really use AI as a tool. Space weather forecasting will be improved, I'm sure, as well as modeling. Modeling can be much quicker if you do some parts of the modeling with AI. Building theory also enable much more ambitious missions where you use autonomy and AI on board. And also, finally, to use AI for improved workflow as a scientist, that will be a game changer. And this is what I think we'll begin with. To summarize, well, better and more powerful data analysis simulations, much smarter, more exploratory, which means that we can do things that has not been thought about before, which require autonomy. And also, though, more relevant. We can do much more better when it comes to space weather forecasts. So I'll stop there.
Thank you, Olle.
Yep.
To the next speaker, my colleague, Chiara. She is the project manager of ESA Phi-Lab, and the title is From Orbit to Impact, Unlocking the Insights from Satellite Data with ESA Phi-Lab, Digital Earth Sweden, and more. You're welcome.
So hi, I'm Chiara. I have a background in actually astrophysics. So when you were talking about like plasma physics and so on, I sort of like remembered when I last had a master student working with me, and in a magnetohydrodynamic problem with AI. That was my first time, to try to connect AI and space. The other one, respect to the one that I'm doing right now. But so also was mentioned that we are here talking about space and AI because both of these two words we are seeing now an exponential growth in them. Like I said, I started to move my first steps with AI when it was concerning my research just 3 years ago, and it seemed like only a little machine learning algorithm could do amazing things. And then all of a sudden, the year after, not even like months after, we had ChatGPT, and then completely revolutionized our way of working already. The same goes for space. I mean, we see satellites being launched like, I don't know how many times per day. Some explodes, but still, actually, it's really nice because like we are allowed to fail, but also we are allowed to try many more things and at the same time. So I think it's like really exciting times for both fields. So I'm here to bring the RISE perspective of this interface of space and AI. I will particularly lift 3 initiatives because all initiatives that are connected to me, so I know what I'm sort of talking about. So I'm a bit partial in that sense, but they're all ongoing. They have different goals. The Space Data Lab and Digital Earth Sweden started in 2019. The first one, so the Space Data Lab, had the focus of try to strengthen the links in the space community, in the space ecosystem in Sweden, because there exist many different hotspots, but we are not very well connected, which is a shame. And it would be very nice to actually talk to each other a little bit more and have projects together. So this was exactly the point of the Space Lab. So let's meet up, let's create events, hackathons, and so on, and run pilots together so that we can establish collaborations and do fun stuff together. We have run an hackathon in 2023. We have co-organized together with Rim Citizen, AI Sweden, and LTU, SVIO 2025. I don't know if any of you attended, but it was a conference that was reviving the fjärrvärldsdagarna that were like sort of dead for some time. But so it was focused on Earth observations. And we're going to run an hackathon as well in the spring. So if you want to participate, you're more than welcome, and stay tuned for that. Then Digital Earth Sweden, I'm going to talk about a little bit like more extensively, so I'll just sort of skip it. And the same goes for the Phi-Lab. I'm here representing the Phi-Lab as well, especially today because I'm the program manager, and I think you can be very exciting for you also to hear about this because it's a funding opportunity for projects. So, okay, these are like, here I zoomed in a little bit to talk a little bit more concretely about the type of projects that we have been running in the past, and some of them are also still ongoing, where we can really harvest the potential of the power of AI and space. So I think we all know that we have a lot of Earth observations, like the data volume that is collected of this data is enormous. So obviously applying AI to those data is like a no-brainer. So here it's an example, for instance, where we can predict the water flow in catchment areas in Sweden. So we can have a prediction of like flooding, essentially. And we can target urban areas or like different kind of environments to study them and predict and help the government and the local authorities to act as soon as they can to prevent damage, essentially. Then we developed a cloud optical thickness mask, which is based on a very simple concept. So we don't have ground truth data when it comes to, it's kind of difficult to have ground truth data for Earth observation. So we generated a synthetic data set that simulates the like single pixels of like similar to Sentinel-2 data. So all the 13 bands plus a ground truth that gives us the cloud optical thickness. So we trained the model on that, and we created a mask. And this is like very lightweight and and performs better than the standard ESA sync classification layer. So it is particularly useful if you have to like run this operation multiple times and very fast. And we also tried this on board of a satellite. So it was very cool to actually test that on board. And then there is like this other project that is done by a team of my colleagues, so I don't really know very much about this, but it is an ongoing process, and you can read soon an article on the Digital Earth Sweden website. So please go ahead and take a look at that. Now, what is Digital Earth Sweden? So this is a project that has been funded by Rim Citizen, like I said, since 2019, with the idea of gathering data over the Swedish territory into a storage space that namely is the ICE facility, like owned by RISE in Luleå. What do we do here is so stream the Earth observation data on Sweden, make them available to the public in an easier way, and also build analysis data-ready product together with analysis tools that are also available to whomever wants to use them. Of course, we also give technical support if you want to use them. So it is a very useful platform if you're interested in using this data. So I recommend you to check it out. Then we also, like, in a parallel stream, like together with making data available, we also try to improve the data products that we get from ESA. So in this case, if you try to put together different images from Sentinel-2, and these are level 2 data, you see that there is this mismatch in the borders. So we implemented a 4CEO algorithm that it's basically a different atmospheric correction that allows you to smooth out these borders. And so we are making this product available for a better analysis, we hope, so that we can avoid this sort of problems. I can distribute the slides later, but these are some links. If you are interested, you can go into the website. There should be all of the other links, but you'll have this slide. Then we come to the Phi-Lab. I don't know how much time do I have, but I probably need to. Okay. So ESA Phi-Lab Sweden is an initiative that started in April this year. RISE is the coordinating organization. We receive funding from ESA and from Vinnova, and in collaboration with RIM Citizen as well. And we also have 3 supporting partners, IRF, KTH, and SSC. What do we do is to issue, I should say that. So what is the Phi-Lab? Phi-Lab, ESA started opening different Phi-Labs on virtually all the state members, each with a focus area, with the idea that this will become like a center of excellence of these types of technologies connected to space. We have been tasked with AI and edge learning for space as like the broader umbrella. Then we are like, besides that, we're more free, so to say, to choose like the like subtopics, so to say. And we are all connected to each other. So all the Phi-Labs are like in a network. So we can hopefully in the future also do even more things together, like joint calls or something like that. But what we do is to have open calls every year, initially for the first 4 years, so from 2025 to 2029. Every year we have approximately a 10 million budget total, and we fund up to 3 projects per call, depending on how much they request as a budget, and each project can run for up to 2 years. This year we had these 4 thematic areas, so AI and edge learning, AI enabling hardware for space, and climate sustainability as more of a request of not like try to keep in mind and factorize into the project also this optic, like of not overdoing it with what you use, and try to make it as sustainable as possible. I'm very happy to say that we have make a decision this year to fund 3 projects, and these are the ones that started. As you can tell, they started. They started in December. No, it doesn't say. Yeah, December or November. So they're very new. They just started. Here you can see, you can read who are involved and what is going to be. Soon, we are also going to publish on the Phi-Lab website like a short summary of what they are about, so you can read a little bit more about them. And we will try to keep, like, everything visible as much as possible about that. Okay, I think I don't have any more time, but you're very welcome to ask questions afterwards.
So, as I mentioned, I'm with LTU, but located here at the Kiruna Space Campus, and looking over here, the audience, I see a lot of our students, and if you're a guest here and not one of the normal inhabitants of the Space Campus, then I urge you to mingle and network in particular with our students during the later mingle in our light garden. I think there's ample of opportunity, so use this opportunity. So let's talk about AI small satellites and some new ways doing space missions. But before, like the others, for those who are guests here and maybe even here the first time at the Space Campus, allow me to talk quickly about who we are here. LTU is very well known. Main campus is in Luleå with remote campus sites in Piteå and Skellefteå. And then far away from Luleå, we have a campus site here in Kiruna, the smallest remote campus, and it's only the Space Technology Division, only because of its size, but not because of the exciting things we do here. And here, a quick overview of the Space Technology Division with the many topics that range from planetary science and atmospheric science to engineering activities from nanosatellites to propulsion, spacecraft avionics, and asteroid engineering, one of the most exciting things you can do when you think of the future of resource utilization in space. Of course, participation in space missions, interaction with industry, but foremost and first of all, education with the 3 degree programs. And I'm sure we have all 3 degree programs even represented here with the students in the room. I like to look into one example that we do in the field interfacing between space and AI. And it has to do with satellites, with small satellites. Now, our students know very well that small satellites means doing space under very, very severe and strict limitations, constraints. Constraints in mass, because small satellites are tiny, in power, because there's not much power you can gain with these few solar cells on board of a small satellite, in bandwidth, small antenna, small power, and bandwidth is nowadays also the bottleneck for many other space applications, but also in performance and memory. And we have students here who I know did recently Bexus. So how limited is the computer performance when you do a balloon payload or a small satellite? It was not, yeah. So would you have liked to have more performance? Yeah. Yes. Would you have thought about running an AI model on your onboard computer? Probably not. Okay, maybe not in a Bexus project. So satellites are the traditional hardware-defined system in space because we are so risk-averse, right? That's what you learn every day in our lectures. Because we are risk-averse, we like to fly hardware again, especially hardware that has already been proven to work in space. So for the students here, what is the percentage of hardware we like to have already with space heritage on board of our satellites? What would you say? How many percentage? 100%. Okay, that's the extreme answer. So no innovation at all on board of the satellite. What's the realistic answer? Other ideas for our students? And there's always an exam, right? Even in an event, in a seminar series. So what would you say? How many percentage normally on board of a satellite? It depends. Well, on what? Okay, how much research? Yes, for research satellites probably more. Yes? Any other answers? What would you think? What would you feel comfortable with if it's your satellite? How much new things would you like to have on board and how much heritage things? You're thinking hard about it. So what's your number? 85. Oh, that's a very good number. Very good. So 85, 90%, 95%. So everything is hardware defined. So that makes it difficult. But in today's world, we see that the demands, Ole already mentioned that, Chiara already mentioned that, are changing so fast. So what if you would like to have a satellite that you send up to space, but with changing requirements, with changing tasks? We have an industry collaboration with Airbus together, have a joint PhD student, and this is one of the very, very wonderful elements and models and examples of a collaboration between subjects here in Kiruna and in Luleå, because this would not have been possible without Markus Lewicki and machine learning in Luleå and their expertise joining forces with us at Space Systems. And the question is, can we use AI to an example, give different tasks to a satellite on a changing base. Every day is a new customer, every day is a new task. An example, one customer could say, I want to know about disasters. Because you don't need this every day. You only need this when maybe you see, okay, let's do volcano detection and eruption detection. When the volcano starts, maybe erupting, but most of the days of the years you don't need this. And then the question is, what can we detect from space? A lot, right, with satellites today. But which computational power do we have on board of a satellite? Very limited. What algorithms can we actually run with this limited power? And how much training for such an AI system is needed? And would we put an AI on board of a small satellite? Right? Normally, when you type with ChatGPT, you basically keep a large data center, a server farm busy. We can't fly that. So we thought about together with Airbus to put this into a commercial off-the-shelf platform like GomSpace 16U satellite, and if it's feasible to fly an avionics system with an Earth observation payload, what you see here, to try if we can do image recognition. Can we detect a volcano that erupts? Can we detect an area that is flooded but before was not flooded? Can we detect an airport that is operating in an airport that is maybe damaged from a natural disaster? The same for an harbor, an oil spill. Can we detect that? Because normally we need to download all the images, and human analysts have to look at these images one by one and detect and determine, oh, there is a disaster. So this is one of the examples where we did this. So you can actually see here down here, volcano. Yes, the AI detected there's not only a volcano, there's actually a volcano with smoke coming out. Ooh, that's dangerous. Very good. Let's warn somebody. Let's not only image process this image, but warn somebody down there, because the 364 days of the year where you don't need to do this, you don't need to download the images, you don't need to warn anyone. The same with airports, and you can see even with clouds, with cloud coverage, the AI is able, after some training, to identify a harbor, and it's an operating harbor. So everything is fine, so no need to send a warning. It's an operating airport, and so on, even under cloud detection. And of course, all of this helps to make satellites more versatile and getting them actually from hardware-defined satellite to software-defined satellites. And we cannot do this alone. Without industry support, without the ecosystem that we have here in northern Sweden with all the industry partners and academic partners, many of them where our students do their master thesis, this would not be feasible because we can only do the research. The application has to go then, it has to come from innovative companies down the road, here in Kiruna and in other places. So that's from my side. Thank you very much.
Paulson is the next speaker. He's the CEO of AceCut, and he will present his title as well.
All right, let's see if we can make the schedule break. Sorry, I have a lot of slides.
We are on schedule now.
Yes, I'll do my best. I have a lot of slides, but I'll keep it very short. Very compressed presentation, I hope. I'm going to try to give an overview of IceCat and use that as a background on what we are doing in AI. And I can already now tell you that we are not doing very much, to be honest. We're taking baby steps. We're trying to figure out what to use AI for and how to apply it to our business. But IceCat as such, we're the European Incoherent Scatter, is what IceCat stands for, radar. Also from a long time ago, in 1975, first operations in 1976, so next year 50 years. A couple of smart people, some of them from here. Why do I lose his name? Bengt Hultqvist, of course, and Tor-Arne Hagfors and others came together and said, in the US, they've invented a new type of technology for incoherent scatter, so studies of the ionosphere. We need it in Europe. They figured out Sweden Norway and Finland can't do it on their own, so they gathered a number of different countries to basically pool their funding and build the world's best incoherent scatter radar that has been operational now for 50 years. But we are also a startup. Since 1st of January this year, we're now a governmentally owned company, third owned by Sweden, Finland, and Norway. So we are officially a 50-year-old startup in that sense. That's a lot of where I put my focus at the moment, starting this company and getting everything put together. We also have associate members. That means basically the users of our systems. So we have Norway, UK, Finland, Japan, and Sweden. They are sort of the core users of the systems. Then in addition, we have affiliate users, which are usually institutes. We have a couple of commercial customers. And this is really also where we're expanding now as a company. Here you also see the geographical spread of our infrastructure. The blue dots are in construction. The red dots are the legacy system, and I will show you what that is. So Kiruna is really the southernmost part of our company. So we're truly an Arctic company. We also have facilities up in Svalbard. So this is a very sped up video that tries to show what we do. So you see a bit of aurora coming in. You see two of our facilities. It's actually a UHF and a VHF antenna, transmit-receive antennas that are standing in Norway. So what we do is actually we transmit radio frequencies in VHF and UHF frequencies into the atmosphere. We encode it in a special way, and we look for the scattered radiation. We basically listen very, very carefully on what comes back. With that, we can deduce a lot of different things in especially the ionosphere, but also we can deduce things from the neutral atmosphere. So the core research that we do is ionospheric science, atmospheric science, solar terrestrial physics, and meteor science. I added this just because this is very new data that our scientists just pulled out. That shows pretty clearly, if I manage to get the pointer going. This is just from a couple of days ago when there was massive solar activity. So this is before the solar wind basically hit the ionosphere. So we can see a massive shift here in the electron density, the electron temperature, the ion temperature, and the drift velocities. And these are parameters that scientists are very interested in to model what goes on in the ionosphere and how. How do I go back? There we go. They're very interested in that in order to deduce what's going on in the atmosphere. Then in addition, we have from our VHF radar in Norway, we were looking in a slightly different direction. But here you can see another thing, that the ionosphere is the charged part of the atmosphere is very, very far down. That gives us an indication that there's a lot going on. There's a lot of, there's a lot of incoming charged particles that pushes the entire ionosphere down. So this is 50 kilometers. And you can also see these effects here, that is dawn and dusk effects that some scientists are very interested in looking at, what happens in the atmosphere. All right, so having very large radars that looks at electrons at 1,000 kilometers also gives us the occasion to look at other things that passes by. So a satellite the size of anything, they show up pretty well in our data. Usually we filter them away because they're in the way. But we're starting to develop things for space debris tracking, satellite tracking, launch vehicle tracking, and radar. We also build next generation radars or develop them. This is really some of the application areas of AI that I will come into. But first, a bit of pictures of the actual infrastructure. So just to give you a feeling for what we operate, this is the VHF transmitter, 120 by 42 meter. That's actually a door up there that you see on top of just for scale, that's a door, human-sized. So pretty big infrastructure, a lot of power. That also means we need a lot of scheduling. We need to understand what goes on in the atmosphere before we turn on the systems. Otherwise, we're wasting a lot of energy. Same here with the UHF transmitter. Also here, took this small video sequence as a sort of example for probably instrumentation errors, stuff where we can apply machine learning to look at gears and look at motors, see what's going on, because it's loaded with tons and tons of snow. Would probably distort some kind of signal at some point. We also have a heating facility, roughly a square kilometer of arrays that we can actually modify the ionosphere. So we can actively pump it with radio frequency to get the response that we need. So we can study effects of our own, do atmospheric chemistry. This is usually where the people with tinfoil hats say that we control the weather and mind control and those type of things. But official standpoint of IceCat is that we don't do that. And then we have our dishes up at Svalbard, where we have one that is field aligned and we have one steerable as well. We are currently in a bit of a project to, is it running? No. To remove these systems. So this is the Sodankylä antenna, one of the UHF receivers. We've done similar things here in Kiruna, where these landmark things have been torn down. The reason for it is that we are building the most advanced radar in the world. Phased array, software-defined radar, also tri-static radar, tens of thousands of antenna elements that we can software control and do phased array beamforming. So this is what it looks like. Transmit receive site in Norway. We have a receive site in Sweden, in Kaisaniemi, and then we have a receive site in Finland. This gives us the ability to transmit from one site and look from two different angles and create the volume. Basically, we can scan the entire sky simultaneously and look at whatever we want to look at. Also, one of the reasons why we're now a state-owned company, because the consequence of this is that we see everything, give or take, which then requires some governmental control. But AI, just to also touch upon AI, we are part of a couple of AI projects. The biggest one is RI Scale. It's roughly 10 million euros. It's a EU Horizon Europe project where we are working together with 4 different large research infrastructures, together with some data centers as well, to look at data exploitation models. And it's from various fields. So it's research infrastructure from medical imaging, it's from space, and it's from, I think there's also some environmental something infrastructure in there. But what we are doing is that we are looking at scientific use cases. One of the things that we are doing is to develop a AI-based decision tool, basically to task our sensors in order to just use it when the geophysical conditions are correct. Same thing, we're doing also some work on machine learning in there to figure out big data sets, what is actually in the data, is there anything wrong with our sensors? Next step that we are not part of that project, but we are looking into, which we, to be honest, we don't really know how it works. Deep learning models using neural networks to actually analyze our data sets. We have 50 years of data, we are producing immense amounts of data. There's a lot of different things that you can deduce using this technology, apparently. We don't know how yet, but we are looking for collaborations in how to do it. Last slide before I get kicked out is just in the development work. We also put a lot of emphasis on the other side of things, developing policies internally for how do we actually use AI as a tool to support our development. There's productivity increase, there's a question mark there. There's a lot of debate going on. Does this increase productivity or not? It definitely shifts our focus from pure software development into another type of development where you maintain, you need to maintain whatever you have developed and ensure that it's secure, ensure how it's implemented. We are, some of our developers that sit especially in Japan are developing actually on locally host large language models in order to, secure our operations. And so we are following this very, very quickly, or we're following this very, very much, but so far, it's not fully implemented, I would say. We are still going back and forth on what are the actual security implications and how it shifts our way of working away from the core of what we're doing. Thank you for that.
And now to the last presentation, Mattias Abrahamsson, Business Development Director at Swedish Space Corporation. Welcome.
So my name is Mattias Abrahamsson. I work with business development at Swedish Space Corporation S-Range facility, which was, oh, sorry, not that one. At the pound, yeah. This was what we started with, rockets, in 1966. Some of you will come out for a tour tomorrow, and then you will see quite a lot of what we have been doing over the years. But now, I got told that we would talk about space and AI. At Swedish Space Corporation, we don't do much of that right now. We have some things, because looking at what we were supposed to talk about was how AI could be used on satellites, and also how to analyze satellite data on the ground. And that is definitely not something that we do. What we do, we are a state-owned company. The company was founded in 1972, but the S-Range facility was actually already built in 1966. We're global. We have about 750 employees. We're placed in 18 countries, 18 locations all over the world. And we do, and we do science and launch services, access to space, either by rockets or near space with balloons. We also, of course, have contact with satellites through our ground station services all over the world. We do spacecraft operations and engineering services in Europe. We actually run GSOC and ESOC facilities, or we have personnel there. And we also, just some years ago, started with the satellite launch and rocket test service, where we will be launching satellites from S-Range in a couple of years. So the companies like this, we are spread out over the world with mainly satellite stations, which are these white blobs. We have in North America, in South America, in Australia, and in Asia, in Thailand. But the main site is, of course, at S-Range here in Kiruna. That's a little bit quick about what we do in the company. Now, S-Range, as I said, we provide access to space. This is being done for a long time with sounding rockets and also with stratospheric balloons. Of course, we also work with producing payloads for these. So a little bit of payload development for balloons, but mainly for rockets, being done in Stockholm, for ESA, which is one of our main customers for big scientific payloads. I'm going to focus more on the balloon side in a bit, because that's actually where we're at least touching the AI environment. Because AI at SSE, we do some machine learning, or at least we've done some trials for machine learning for anomaly detection in satellite scenes, because we do work a lot with satellite data. Of course, we do a lot of coding, and actually a lot of trials for that, using coding for, among other things, using Copilot. There's a concept of using AI in the future for satellite ground station scheduling and planning. That's something that we see AI that we could use it for in a good way in the company. But what we have actually started already with is an ongoing study about AI-controlled ballooning. And what we're actually now looking at as a pre-study is the wind situation at northern latitudes. And because AI-controlled balloons, this is an image from Google Loon. So Google started a project in 2011 called the Loon Project, where they were planning to do internet connection for rural areas by balloons. So the idea is actually to send up a balloon that would fly eastwards at a fairly high altitude, between 18 and 25 kilometers. And then, as it was going and broadcasting internet connections down to the ground, where you had bad internet connection, I would say. And then as it were traveling out of that area, it would actually lower or raise to another altitude where the wind was going in the counter direction. And then you could sort of like travel around here in loops for a long time. They were using super pressure stratospheric balloons, not very large balloons, about 15 meters in diameter and the same size. You will see a picture pretty soon. A small payload, 10 to 15 kilograms. But they could fly for a very, very long time. So these balloons have been flying for 200 days. And they could also control them in a very good way. they flew. They actually launched these in Northwest America in Washington State or in Oregon. And they actually flew them down to Kenya to do station keeping over Kenya for a number of days. Then after a while, the winds you can't stay in that area because the wind will sooner or later push you out. But then they had another balloon coming down from Oregon, flying down there. So they actually have flown, can't remember, it was like 100,000 hours with these balloons. They have a massive amount. Unfortunately, in 2021, you start to get large satellite constellations. So I would say Starlink killed this project because in 2021, they didn't fly it anymore and they actually sold all the assets. And there's a lot of interesting information about Google Loon project that's just open, free for anyone to look at and continue their work if you want to. The balloon looks like this. It's a super pressure balloon, so it's closed, filled with helium, but the idea is that you have a double envelope in it. So what you do is air ballasting. You have one half which you can pump air into. So you actually use air from the atmosphere to make the balloon heavier, and then you actually get it to fly on a lower altitude, and then you pump that air out, and then it will rise again. So you can fly it because you don't lose any gas inside, and you don't lose any ballast. The balloons we fly from SSE is what we call open envelope balloons, or zero pressure balloons, because they are open, you have the same pressure inside and outside of the balloon. But that means that you will lose gas sometimes, and then you will have to use like small metal grains to actually release as ballast to get them to get up in altitude again. But these, they can fly for a very, very long time. Right now, we have 2 manufacturers that are using these types of balloons. So it's a French, it's called Balman, that Knes flies, and it's a Thunderhead balloon, which is flown, among other things, by NASA, but they're also commercially used. We want to try this. So just as an idea, this is actually also the type of balloon that was flown over the US in 2023 from China. So the same type of balloon was supposed to do station keeping over China for telecommunication work, because you can use them for telecommunication or for remote sensing, I would say. They were, what's told, they lost control over it, and it actually drifted with the winds all the way over to the US, where it was shot down after a while. So the idea of using these for science purposes is that you can keep them for a long time, and you can actually stay over an area. We would like to fly them with AI control over Sweden, Norway, Finland to do long science measurements over the area. For, I would say, dual-use missions, you can use them for reconnaissance. You can use them for, if you send up, you call these for stratolites, so stratospheric satellites, because they can be used as a satellite, but they're flying in the stratosphere. So I'm actually project managing this project that we have right now, where we're trying to get the wind data, because we know that you can fly them on quite low latitudes, between the tropics and up to, I would say, well, the US, because you have winds there that are actually counter each other. So you can fly them west or east by just moving in altitude. If that works also over the northern hemisphere, over the polar region, here and in the South Pole, we don't really know. So that's actually the study we're doing first. Hopefully to continue this with real flights over the area. And these fundings we get from the Swedish National Space Agency to do these tests. So that's a quick thing about what we do with AI at SSE. And for those that come out tomorrow, we'll talk more about what we do in other areas also. So thank you.
All panelists, because all the presenters will now be my panelists here. So please welcome up here, and we will have a handheld microphone somewhere. And then we maybe need it for the audience. Yes. Okay, so we have all the presenters as the panelists, and how does that look like in the picture up there? Good, yeah, fine. And I will start with this geopolitical tension a little bit. So it is a sensitive thing, of course, but maybe we can have some ideas what could space and the intersection between space and AI, can it be used? How can it be used? Could you think of anything good with that or bad? Or what can it be used for? Olle, maybe start. We go this direction.
Well, the geopolitical situation when it comes to space science is mostly connected to the countries that we can collaborate with. And of course, Russia, Belarus was out some time ago, whereas China is something that is not so easy these days or impossible. Unfortunately, even United States is difficult this time. But space science is something that we really try to do as a global endeavor. And in particular, if we want to do exploratory missions, then doing that together is the best way forward. So I really hope that we can come back to doing that in the future. Other issues?
Chiara?
Okay. I should say that I'm not a very big dual-use expert, so I will just try to give like my opinion on that. But so from the perspective of Earth observations, we can see that by applying AI, we can detect very many things. Like if you look at, for instance, SAR data, there are huge assets for dual use. So I think that there is an enormous amount of use cases that can be developed in that sense with AI and SAR data, especially if we move towards more the onboard AI sort of projects. But also, I mean, we all kind of like rotating around the new space thing, and we know that like if we look at the US, we know that these two things are very connected, and it kind of looks obvious that if we want to start that, somewhere else also needs to come from like some sort of like dual use, support, so to say. But yeah, I'll stop here. Yeah.
All right.
Philip? Yeah, you have.
I have this one, so you go ahead. All right. Are you? Perfect. I'll probably echo your sentiments a bit, and I think historically space and defense have always been interlinked, and I think from a space science point of view, there is an unfortunate consequence of the geopolitical situation or an fortunate consequence, I would say, is that we should make a fortunate consequence. There's a lot of technology development going on. There's a lot of funding unlocked due to the geopolitical situation that we are in, where especially dual-use type of missions should also be able to boost space science and be able to, in my view, the defense sector should be able to basically, through their own requirements, set up an industry base in Sweden that could, be the outgrowth of what we do in the academia, to really pick up on how do we create products and services based on the scientific knowledge that is available in Sweden. I think that there's a real opportunity given the geopolitical situation that there's a lot of money coming into it. And AI for Sweden should be a perfect match because we are so few people. We need someone to help us in doing all of these things. And I think if we can figure out the way of implementing AI, both in development but also in data processing, I think Sweden can do a lot.
Yeah, I can just tag on. So actually the grant we get from SNSA for doing the study is actually co-shared with the Swedish Defense, because this is their dual-use call, so to say. Because of course a Stratolite, as I like to call it, could be used for reconnaissance missions for the defense, as well as it can be used for a science mission. It's a tool. It's a vehicle. Whatever you use the vehicle for. But we need to first to use AI to figure out if that vehicle works. Looking at the geopolitical situation from a science point of view, So, for example, we had opportunities a little bit more than 10 years ago to actually do circumpolar flights around the North Pole. So we had really good cooperation from SSE when it came to the Russian scientists. So we managed to fly a 14-day flight, ended up actually in Russia, got the payload back after the flight. Fortunately, we can't do that anymore. From a science point of view, it would be perfect if we could do that in the future also. And then, as Olle said, we don't even know what we can do with the US because the science, we've always had balloon flights from the US coming in every 2 or 3 years, 4 years sometimes. Now there's not as, the science budget has sort of gone away in the US, both for rockets and balloons, unfortunately. So the geopolitical situation is shaky, I would say, right now. But, yeah.
Okay. René?
As Philip already mentioned, and those of you who know space history know that the origins of space flight are deeply rooted into dual use, so in the non-civilian part of rocket technology and payloads and things like this. And one person's Earth observation specialist is another person's intelligence, surveillance, and reconnaissance specialist. So there is always dual use when it comes also to Earth observation data. Of course, the example that I showed with a company like Airbus together is clearly an example that's also usable not only for disaster mitigation and helping with disasters, due to the International Charter, an example, but it's also possible to, of course, observe infrastructure. We talk a lot about critical infrastructure in today's world and how to monitor and secure our infrastructure, and AI will be an important and powerful tool for monitoring, but also for securing when it comes to cybersecurity, example. And the same goes for space assets that are also very critical for us. And that means there's always both sides. Nevertheless, I think we should not forget that despite of the geopolitical tension, we also as a country have to make sure that we have the capabilities that we need for ourselves, our friends, our partners, together with them, to secure the way how we do things and how we want to see our society develop. And that means we look into AI, of course, also as a tool for securing these capabilities in the field of space.
Yes, thank you, René. It's a tense question, of course. I asked first, but maybe I have a lot of scientists and researchers here in front of me. So, of course, I have one question that maybe will lighten them up a little bit. We heard a little bit about the funding. Imagine that you have non-limited funds, and you could do whatever project you would like. What is that project, Olle?
That's an amazing question. Definitely, it's going out in the solar system, and I would say that we need to do the moon first to get to the moon and learn how to be on the moon, which means a moon base at the South Pole, and then of course the next step is going to Mars. That is a huge undertaking. Which humanity will do. It's a matter of time, definitely. We are driven by this, by the very nature of human beings. So we'll definitely go to the moon and we'll go to Mars. But again, I can't say how.
And why?
Well, because that's the way we are. We're explorers. Yes. We are. I mean, we now know that there are water ice in the permanently dark craters at the South Pole of the moon. So that means that we need to go there and see, can we use it? Can we build a base, which means that we can sustain a base for a long time? If we can do that, well, the next step is go to Mars and see if we can survive there. So it's sort of, yeah, that's what we want to do.
Okay, Chiara, what do you want to do?
I'll say that together with an international consortium of colleagues in astrophysics, actually, we submitted a proposal to an ESA call for a medium-sized mission. That was like the poor version of the idea. So if we would have like infinite amount of fundings, we would have proposed of launching a very large set of sub-millimeter antenna in space to do synthetic images of the sky, of the universe. I mean, stars and black holes and galaxies and so on. So basic research on space. That would be amazing. So when you said a phaser antenna, I was like, yes, somebody else.
All right.
Okay, Philip, what do you want to do?
According to my job description, I should talk about ground instruments, but I won't. I think, let's say that the most useful thing for Sweden at the moment, slightly different take on what you're saying, would be a Earth observation constellation. A dual-use Earth observation constellation with the intended purpose of kickstarting Swedish industry and really connecting academia, industry, and all of those aspects. Also the back-end aspect of that, data centers, AI processing, all of the other things that we are doing in Sweden, connect that. In Sweden, we are super good at everything that we're doing, but we are looking through straws in different directions. If we had infinite amount of funding, I would get everybody around the table and say, all right, how do we solve defense requirements, civilian requirements, and science requirements? How many satellites do we need? What type of instrumentation? What type of data processing? What type of AI? That's my dream scenario, because that would generate jobs for these guys. It would generate a lot of science for you, a lot of launches.
Yes, great.
Yeah,
Mattias, what do you want to do, Mattias?
Well, what Philip said, but then also tag on for the near space environment. So I would have a bunch of high altitude, long endurance platforms like UAVs on high altitude, or these AI controlled balloons, or similar, or even just feather balloons, but because these could also be used for like dual use when it comes to looking out of the environment over the Baltic and these things. But then, of course, also building out the launch capability in Sweden would be great. So, yeah.
So the blank check for an academic.
Yes.
Okay. Right, Per? We are on for that. I always like to say that Kiruna is a very, very unique place in the world. Maybe one of 3 places in the world where, as a student, you can come here to the campus and have an idea for a payload, for a balloon or a sounding rocket. You develop and design it here on campus. You assemble and integrate it here on campus. You test and qualify it here on campus on the LTU side, or with the help of IRF on the IRF side. And then you drive 40 minutes, 35 minutes if you don't follow the speed limit, and get to S-range, have the payload in the trunk, and put it on a rocket, and you guys launching it. And this is, with Rexus Bexus, one of the most successful education programs unique in the world. So if I have the blank check and still want to follow my dream, then I second Ole Norberg, and I would say, let's expand Rexus Bexus to Lexus, lunar experiments for university students, and make Kiruna the only place in the world where you can come as a student and build a lunar experiment, and you help us launch it, more launches for you, and have the unique place that students can come to LTU, the only place in the world, and encounter building an experiment that will land on the lunar surface.
Oh, thank you. Great project.
Good one.
I would like to open a little bit for the audience. Is there anyone that have been thinking about the question now? Björn, here.
Thank you. I'm Björn Ekelund. I'm with Ericsson. I'm also the chairman of IVA South, actually. First of all, I'd like to thank Olle for running the magnetometer. It's used by thousands of ham radio operators around the globe. I'm not sure you are aware of this. So it's a highly appreciated piece of instrument that's used, has a big civilian usage, actually. But my question is really for Philip. We saw really nice pictures of AceCut 3D, but it's still years before it's going into operation. What are the challenges?
Challenges. Yes. No, building the, as you saw, we promote it as the world's most advanced radar. That in and of itself tells you a bit of the story. We are, there's no official timeline yet, but we've started to drop an official timeline. So we intend to have something operational, subset of the system operational during summer next year. towards the end of the next year, have basic capabilities similar to the ones that we have today on the legacy systems by the end of next year. But there are the difficulties is, in all honesty, it's engineering. It's engineering work. It's always engineering work that you cannot really foresee the problems. When you're building a new type of system, it's always you're going out into the unknown. You can plan as much as you want, but in reality, usually comes back at you at some point. And we're struggling through some of the end phases there on some electronics that are very important for the system. But majority of the system is actually in place. So it's minor things before we are getting there. So in 2027, I think we will be, rather ramping up and starting to deliver a lot of science.
Okay, thank you. Thank you very much. Any more questions from the audience? Now you have the opportunity. It will close soon otherwise. Here? Okay.
Yes, hello. I was wondering if right now you face any difficulties in regulation regarding AI, or if in the future you can have difficulties with AI regulation, either from EU or Sweden or laws and so on.
Anyone that would like to?
Of course, as a governmental institution, we are very much obliged to follow all the regulations that are there. Do we feel limited currently? I would say no, because we are still in this pioneering phase where we try to catch up with learning. Nevertheless, especially as an educational institution, and Per knows this much better because there's enormous efforts, even a committee in Luleå to deal with that, is that from an educational point of view, this is a huge challenge for us as an educational institution. If you want to know more, please approach Per and ask him about his experience of the last 2 years. I think this was probably mind-blowing, all the things, how fast you have to react on new developments. Because you see this as students in your everyday activities. You use AI, of course, and it becomes so normal to use it as a resource. But of course, for us, it's also important to catch up with all the requirements to fulfill when it comes to evaluating, grading, judging your efforts, and what is you and what is maybe AI. And these things are not so simple. And we make this not simple for ourselves as teachers. We try to make it as transparent, as fair as possible. But with a rapid development in AI, that's not so easy. So, of course, this will be still challenging in the hopefully not years to come. I think we have to be fast because everybody else is trying to be fast and trying to jump on that train. So that, of course, will be a challenge for us, I would say.
Thank you, René. Yeah, Chiara.
I have
Yes.
Yes. So yes, it's a big problem, and right now there has been a lot of discussions talking in other areas. Like for instance, at RISE, we have several projects already. We have run several projects on the EU AI Act and ethics and explainability and so on. When it comes to space, it's not that well defined. So right now at RISE, we have just started with a project that is very big. It's called AI Factory, MIMER. Within that, there is a specific part of the project that offers the possibility to have sandboxes, like sort of technical sandboxes where you can explore these sort of problems with experts, of course, within the legal and domain expert. In this case, is going to be space. So we're planning to do something like that because it is still very uncharted territory, I would say, but we do need that for sure.
Can I just add a bit? I mean, there's not only the regulatory issues that you mentioned, but also maybe ethical ones that we need to be aware of. Because if you remember the staircase I showed, we're just at the first step, and we have already seen challenges. As we go up that ladder, the challenges will just become bigger and bigger in terms of for example, ethical things. Jobs will change. There will be jobs that don't exist in the future, and there will be new jobs. And I was thinking about this issue with, for example, peer review of papers. Will AI? I'm sure that people use AI to do peer review, part of the process in science where you judge your colleagues' papers. But what will happen in the future? We don't know.
May I just comment on that as well, because the regulatory question is very important. We've seen it time and time again, especially in the space business. The unfortunate reality, and I might be stepping on everybody's toes, is that Sweden is, again, a small country. We have very limited representation in Brussels. History gives it that every time Brussels tries to centralize regulation, it's usually not in the interest of the smaller countries. It's usually in the interest of those that have a big voice in the European Union. And I don't think we should be naive in a sense to say that Sweden will have a big influence of whatever happens. So given how the industry develops and who becomes the big player in Europe, they will have a very big say in also how the regulation develops. And that will have a very big impact on how we can implement it in Sweden. That's usually the way it goes. And so I think that's a very good question, and you should very early on start pushing Swedish government to actually be involved. Don't sit back and wait for quarter-pair and vote. That's not really the process that works in Brussels.
Yes, thank you. We're going to move to another question.
Well, thanks. My name is Gabriela Schützer. I'm with the German Embassy in Stockholm. Okay, my question was quite similar, actually, because I wanted to know from your experts in what way the non-existence of a European space law actually hinders or maybe enables your research.
Okay.
Well, from the science point of view, I would say there's not a big challenge. So I will leave the microphone to someone else.
I can answer on a personal basis, perhaps, because I was very much involved with launchers before at Esrange, working very much with trying to affect the European Commission in different ways. I think we worked together with many small countries to keep space not regulated by Brussels. That was also the case for I think it was the Lisbon Treaty, when they actually did an exception for space, because there's geographical obvious differences between different countries. You cannot have one rule for all countries, especially when it comes to launch, where it's population densities, different traditions over decades and decades, and all of a sudden it's to be regulated from Brussels. From that point of view, we saw a big, the way it was written now in the report that was published in July, I think, Esrange could say, let's stop launching. So it has immense implications, and it's also very little representation from Swedish side in those dialogues. We've been trying, but it's a very difficult process.
And it's the same not only for launches, also for flights. So when it comes to balloon flights, they are also trying to get that to be a common EU regulatory thing, which is not making it easier, actually, because the extra rucksack that you get on, you have to work with everything, and you have to, even for us, they sort of meld the autonomous UAV flights together with balloons that just drift with the airflow and can't really go in any other direction. But you still have to have like a bunch of things that you work with from a regulatory basis. So it's not getting easier when EU starts to put their finger in stuff.
Okay. I see the timing is going. I have a personal question that I would like to have the chance to ask, because I'm in data center research. These big server buildings with a lot of servers. And there's a couple of guys in the US, you probably know them, that have been talking about sending up data center in space. So, and those data centers, they would interact with each other and automatically do things. So send up a 1 to 10 megawatt compute cluster in space. and then it's going to happen a lot of things up in space. Is that realistic, or is it kind of a...
I guess it's doable. You have lots of power, solar power, so it's green, and you get the cooling. You can arrange for that, but otherwise, I'm not sure why you would do it.
Okay.
I followed that also with interest, as I always follow as somebody who lived for many years in the US, entrepreneurial thoughts in the US. And I have to say, this seems to be now the latest idea what to do, entrepreneurial in space. Of course, as a spacecraft person, as a satellite person, I'm always rather skeptical and very conservative when it comes to the point, how much can I put in one satellite? And as Ole correctly said, the advantage is that the electrical power certainly would come not totally for free, but it would come rather cheap. But then, on the other hand, when you compare with data centers on the ground, the amount of power that you need exceeds everything we ever did in space so far. So that's beyond a point what we have demonstrated and done yet. And the question arises with all the rat's tail that comes with it. So how many launches do we need to bring up all this infrastructure and all these materials? Then people say immediately, yes, I know, he will be happy, but at some point he will be not happy anymore if he can't launch anything else anymore. And even this will not be enough. But then it comes the red tail saying, okay, people say then, at that point, we really need a space economy, a space circular economy. This will only be feasible if we use resources in space. But who will do the initial investment for that? The second thing is power is one thing. You can ask our students, the moment I power something, I have excess heat. What do I do with the heat? Very problematic at that scale. And then, of course, why do people think about that? And that has not something to do with the fact because it's cool or fashionable to put things in space. It has to do with legislation. You should look into who is interested to put data centers in space. Because if you put it in space, if you do it right, you can do it with outside of legislation that might hinder you on the ground. And the question is that good or bad? Can be both, because it could mean people can do things with data that exceed basically partnerships on the ground and are hindered by bureaucracy. On the other hand, it means also certain people can do things with data that we cannot legally control anymore. And the question is, what of the two parts do we want to have? Do we want to have the benefactor for all of our work? Or do we want to have the James Bond villain who tries to control the world? The span is wide.
Yes, and there is an EU project with Airbus involved and a couple others thinking about this. Anyone else want to comment
that the good thing with if someone will start trying to do a data center in space, due to the fact that there is so much things to launch, there will be lots of launches, which means that the cost of launch will go down. But then you can start using those launchers that has to be developed for other things, because having a space economy, like factories in space, other factories in space, maybe not a data center, but having some production facilities in space, that would be facilitated by this demand of having lots and lots of launches. And I'm just thinking that Starship probably would be the one to start doing something like this, because then you can launch a lot. And then, of course, merging things in space, you have docked stuff in space for ages. So, yeah.
But we want to keep it sustainable also.
Of course.
We all want to do the responsible thing. And thinking just about endless number of launches might be also not the responsible thing to do in today's world.
Okay. Any comments from Chiara or Philip before we close?
I'm just trying to figure out the economics of it. Perhaps it's the banking sector that's looking there.
You got the blank check.
Yes. Yeah,
okay. Okay, we are at the end of this panel. I am really happy I was able to ask that last question, my own thinking and thoughts, my own question. I will thank the panelists for presentations and also for taking part in this little discussion around this interesting area of intersection of space and AI. And I hope we can come back to that later on again. Thank you very much. Thank you.
Yeah, I guess this is on as well. Yeah. So on behalf of IVA, the Royal Engineering Academy, a big thank you for the panelists and for Torbjörn. I think we have some small gifts for you. Eva told me to summarize this day, but I'm a professor in geology, and now we're up in space. So I guess my take on your last question here is that you do everything in space. You start with the extraction of the raw materials, and then you build your computer data centers up in space. So then you don't even need to launch. But another reflection from my side, of course, is that it's not by coincidence that we are here in Kiruna talking about space and AI. I think from a Swedish perspective, the real center of gravity for what we have been talking about today, and I think, René, you touched on this in your presentation, that we are in Kiruna, we are talking about space, and this is where all happens. So I guess a reflection from my side, being chairman of the board of IVA North, is how do we utilize this immense knowledge to make an impact, both inside Sweden and also in the European context, because I think there is so much fantastic stuff happening here. And I'm not 100% sure that everyone knows this in Stockholm, for instance, and for sure not in Brussels. So I think we need to come back to this, and we will have more similar style of seminars here in Kiruna for sure, down in Luleå and also in Stockholm. And again, a big thank you. And then some